Hi there, this is Shrikant. Namaste everyone, and here I am continuing to into the educational app developments. And I've been developing these Moodle courses for a long time now. Engineering graphics was implemented last year very successfully, and this year I was planning to complete course development on kinematics and machines. But uh, another job opportunity came up, and um, I decided to join that. I don't know whether I'll be coming back to these educational course developments in the future if the new company allows me to continue developing it, or whenever I get a time to do that, I will definitely continue to do so, but I'm not really sure how far I'll be able to do that henceforth. So, okay, let's go ahead and see what we have around here. So this is a course in kinematics of machinery, which you can see around here. And I was planning to completely develop it and make it accessible to students. But as I told you, I've decided to change the company. I left the college, and let's see what we can do to complete it and get some tips about making the course template even better. Alright, so you can see this course is divided into certain topics. The general topic has various general things like about the course, talks everything about the course, how it's to be used, and stuff like that. You can see that it has been divided into main topics and subtopics. The first is about the introduction to Moodle, so that students who don't know what Moodle should come to know about it. And again, there are two pages. You can pause the video if you want to read through it in more detail. So this page shows everything that is there in the course. So in general, you can see that there's a discussion forum, then there's announcements forum, glossary of definitions, lists all the terms and the definitions that are used in the particular course. Syllabus and course objectives. It's supposed to give an idea about what topics are going to be studied in the particular course. And then we have, of course, the demo test, which is a kind of quiz which the aim of which is to make sure that the students are able to attempt all the different type of questions supported Moodle, to the best of their ability, so that students don't complain later that they were not aware about different kind of questions which appear for the first time, and make the situation awkward for the person who is making the course and the teacher. So that's the aim of the demo test. And then we have a separate topic for each unit, which has books which contain notes. Then we have the gamified quizzes, including Bloom's taxonomy. First, you have to step up and remember level, then understand, and apply, and you can go ahead and I'm developing higher levels as well. But I don't think quizzes will be enough for that. You may have to go ahead and use other tools in order to test their abilities at the higher abilities. And then we have the MCQ, which just is an upload of questions obtained from different sources, like books and all, in order that we're obtaining. And finally, in the conclusion, we have feedback, where every student is supposed to give feedback, and then we conduct a survey and find out. This survey was provided in Moodle. I wanted to say, I didn't mention that one here. And it has various questions which allow us to find how the relationship between the educator and the student was. So this is clear to you. So just open it here. ID and password information about that. And yeah. So here are some instructions to the students about maintaining their IDs and passwords, how they're supposed to maintain it and stuff. course, there are some warnings, but misuse consequences if they share the password and ID with other people and make other people do this. And there, of course, need to be some consequences, because the end result of going through this course and coming out successfully, clearing all the quizzes, should be that the student would have become perfect with everything that we're teaching in this course. And if the student shares the ID with someone else and makes someone else do all these quizzes, then he himself or she herself won't be gaining all the skills necessary for doing malpractice kind of thing. And that's what we need to allow. No, we don't have to allow this, and that's the warning word. That is followed by everything about the course. This one is got to be changed for every course that we're dealing with. So here we have the kinematics of machines. The next one is just course objectives and outcomes. Course outcomes are listed on here. So we have a total of 6 course outcomes listed here. The sub-course outcomes also have tried to list it, and I was going to just do it for 2 courses if I do. So the next thing we have here is objectives. The things we faculty would to offer to the students. Outcomes are the abilities that students are getting at the end of the course. This is, of course, the complete syllabus, which is divided into 5 units. You can see each unit is subdivided into other subtopics, you could say, grouped based on similarity on the topics that we're dealing with in that particular course. So first unit deals with the introduction part, terminology. We are studying a few examples by the inversions of 3 chains. Then we have analysis, where we are finding the probability using different criteria, the Kurzweil, crypto, Kirchhoff's law. We have a brief introduction to crypto curve and Robert's law. In the synthesis, we are briefly going through basic introductory parts like synthesis, dimensional synthesis, and types of this, and we'll be applying it briefly for 1 or 2 examples of quadratic plan mechanisms. So that is what the unit 1. Then we have unit 2, where we are studying all the different mechanisms that are in use. We have the straight line mechanisms, approximate and exact, both. And then we have some other mechanisms like the parallel ruler, illicit tongs, universal drafting ratio, pantograph, and chain of mechanism, the hooks, joints, and we have bell traps and chain traps. Conditional correct steering. We have to study 2 examples of steering mechanisms as well. It is the Davis and equivalent steering mechanisms. Unit 3, even though the number of topics appear to be very small, but this is an entirely a problematic part, and students would have to do diagrams in order to diagrams and calculations in order to final results. This is going to be very difficult for students, most students, because with this kind of problem solving, they might never have come across. Even in engineering graphics, they hardly do any measurements from the drawings that they draw. And the end result of the drawing itself is the solution for our question asked. Because here, we have to not only draw the diagrams, but we have to get measurements from the diagram and use them to continue making some calculations in order to arrive at the final result. So we'll have the velocity diagram, we'll have to understand the acceleration diagram, and then there is an additional diagram method for solving velocities, that is the instantaneous center method, because there is a bit of theory involved, like body is based on forward axle and stuff. That's okay with it. Then the 4th unit deals completely with cams and followers. We'll have to study different types of cams, different types of followers, and we'll have to also study different kinds of motions the displacement and its derivatives. We'll have to first study, then we'll have to study all the different types of motions that are designed, different types of custom motions that are designed. Four of them are in the syllabus. We have uniform velocity, parabolic motion, or uniform acceleration deceleration, and then we have simple harmonic motion, then cycloidal, and then graphical synthesis of planar mechanisms with knife edge, roller, or flat base followers. Eccentric circle cam with translating roller follower is the first thing we'd have to study. And then we finally have the gears. We'll have to first start with studying the terminology used in the gears, like the different parts of the gears, and the terms used for defining the geometry of the gears. Lots of these terms involved around here. And then we might come across some of the formulae as well, and we have to understand what are the problems we face in the gears, like interference, and how to solve them, what are the conditions for avoiding interference. We can start free formulae for pushing the force. We might have to take it from the diagram, and we have a slide on velocity and the steps. And finally, the last part is very interesting. It's not only is it very simple, but has applications possible. Although your trains, a system of gears connected together, and we must be able to solve problems finding velocities of some of the gears when velocities of some of the gears are given. And then we have three applications that we must be able to do around here. The first one is the application of the clock, which mostly uses of reverted epicyclic gear trains. And then we have gear parts, which mostly deals with parallel reverted gears. And then we have differential, which uses bevel gears in order to distribute power from the engine and four elements in an equal manner. So that's what the whole series that we have studied. Of course, there is a section where we have a bit of information about how this and many parts are going around it. Okay, there's not much around here, but what do we have now? It's going to do. So I need to make a few notes about what's missing here. So how do we plan to make distribution methods with marks? So one way to do is to make it compulsory for them to solve quizzes that we can understand and apply for all the units. And once they have completed applicable quizzes for all the units, only then they should be able to go for the last part. And the last part is conclusion. Only then should the feedback of overall kind of a quiz should get unlocked. And the overall marks need to be decided based on weightages given for all the tests that they are doing for a particular course. Now, one problem that I came across, and the way I think it needs to be solved, is that you must have seen in the syllabus, each unit has been subdivided into a group of topics which are similar to each other, interconnected, you could say. So I think it's better if we separate set of quizzes for each subtopic, so that as soon as that subtopic is over, students can go ahead into the quizzes. So they'll be able to do the quizzes more often instead of waiting for a complete unit to be over and then going and solving the questions for that particular unit. That would mean that the number of topics are going to multiply. So if we just have around 5 units around here, so those 5 units will expand to something much larger. That's what's going to happen. You need to be careful about that. Mm. Mhm. I'm sorry if I'm making you wait a lot because I'm not really into this thing. I'm new to this thing, so I'm still learning to bring everything together. And all the live changed. It's something that I'm also trying to learn as we speak. If it is not very clear to you, and if it's taking a lot of time for me to put things up in front of you, if it's very slow or something like that. Right, so I need to take a decision now. And in order to solve all this, I should think it back to model gift. Yeah, so this is the place where I'm creating all the quizzes. Right. Yes. Okay. So the main challenge here is to ensure that difficulty for every quiz is almost same. We can take Bloom's taxonomy levels, but that doesn't ensure that the difficulty will remain the same. So balancing that is can be a major problem. So most of the times I end up thinking that dividing the quizzes based on unit, each unit getting a separate series of Bloom's taxonomy gamified quizzes. That's how it's supposed to proceed. But having done graphics, engineering graphics in a slightly different way, that I could do this as well in that particular way, but I don't think that is possible on you. You have to stick with the units, with unit-wise quizzes. Let's see what else we can do here. So in the course for second unit, there are so many straight line mechanisms. And for all of the straight line mechanisms, I am supposed to create nodes for them. I have created a lot of nodes. And here somewhere, I don't know, is it, there is a problem happening here because it's not showing the entire thing that it is supposed to. See what we have here. This is unit 1 auto, okay. Any other questions? Let's see what we have here. Again, the same thing. It's typing somewhere here. Is that the limit to which it can expand? Something like that. Okay, let's see if we're able to get that opened around here. Because they are knowledge and we should go to kinematics of machines. And this is where this isn't. These are all documentation prompts. Oh, you answer keys. Can't imagine. I think this is where all the names are present. And they found it out. Oh, yeah, I guess these are the latest notes. So let's go ahead and see for unit 2. Okay, unit 2 was velocity analysis here. So I was displaying all those things. What about unit 3? Let's see. Okay, so unit 3 was completely different. It was actually from dynamics of machines. It is supposed to be from dynamics of machines. And unit 4. Where did we have the straight line mechanisms? How did that is remove it completely? Yep, so it's games and followers. Last one is supposed to be gears. Yeah, gears and blue trains. And talking about friction and other stuff is present here. That was with unit 1. Okay, Hooke's joint is unit 1. maybe the straight lines were included here. Probably not so. No. Straight line mechanisms are not even a part of the syllabus earlier. It's ridiculous. Integral Geneva mechanism, Hooke's joint. These are the only things we're doing with. But then, what is the application of straight line mechanisms? Well, they're easy to maintain and they make the most possible in straight line. That's kind of the whole point about straight line mechanisms, isn't it? So what did they expect? They just thought that probably it's already included with quadratic chain, because most of the Fibonacci mechanisms which are not exact are already quadratic chains. So it can just be application of Fibonacci mechanisms. Could be. That way could also be true. So then we had to put up an entire new thing to actually be able to do it out. But heat transfer is always coming in here. And this is where the kinematic emissions actually starts. So derivation part. So this is part two.